Firstly, a uranium pellet is placed into the fuel rod to be lowered into the reactor's core. In the reactor core, the uranium is hit by neutrons, so fission occurs, producing large amounts of heat. This then continues in a chaining reaction where each neutron produces and splits a further uranium atom. Each fuel rod is packed with thousands of uranium pellets which produce an immense amount of heat. As the heat is pumped through pipes to a water reservoir, it creates steam to power a generator. This generator then turns and spins, producing electricity to be used.
The inception of nuclear power took place on December 2, 1942, when Enrico Fermi and his colleagues at the University of Chicago engineered the first nuclear chain reaction. This would lead to the commencement of the Manhattan Project, the famous project which gave birth to the first nuclear weapons. Fermi's work would also lead on to the construction of nuclear reactors and hence the nuclear power station. The first working nuclear power station that produced electricity for a power grid was built in the Soviet Union in 1954. Since then, many more have followed. There have also been some notable accidents associated with nuclear power, namely 3 Mile Island, Chernobyl and Fukushima, to name but a few. Many countries around the world are currently using nuclear power as a source of energy. Others plan to buy into the idea, and others, particularly in Europe, are planning to move away from nuclear and phase out.
One of the more controversial aspects of nuclear power is the process of decommissioning when the facility reaches the end of its functioning lifetime. This process entails the removal of radioactive waste from a retiring facility to a new contained location. To prevent the theft and/or leakage of these hazardous substances, sites must be constructed specifically to meet the necessary safety criteria and be subject to continual monitoring once in use. Each of these factors contributes to the mammoth expenditure required for decommissioning a nuclear facility, where in some cases it is estimated to be 200% greater than the cost of construction. With the NDA approximating a contribution of $2.09 billion from the UK government over the following year alone, decommissioning finds itself exposed to the various fluctuations in economic climate. Although some organisations have benefited under the implementation of nuclear decommissioning, the question remains whether the pursuit of nuclear power will still be of merit once Europe's first generation of sites has been decommissioned.
We as the Green Party believe it to be a very good thing, as cancellation and thus the phasing out of nuclear power across Europe will avoid the costs and dangers of nuclear energy and waste being passed on to future generations, which we as the Green Party so ardently stand for. Absolutely not. Again, we as the Green Party believe that nuclear energy is likely to be significantly more expensive per unit supplied and too slow to deploy to meet our pressing energy needs. An obvious point of contention surrounding the decommissioning of nuclear power plants across Europe is that of the waste that will be supplied. The Green Party manifesto released in April 2015 specifically states that we will put funding and money into how to get rid of this waste safely. Any money earmarked by the previous government for new nuclear stations and nuclear development and construction will be reallocated to energy efficiency measures and renewable energy infrastructure.
Welcome to the European Nuclear Power Report. Today we are focusing on the 3 big players in the nuclear industry. Germany's policy of continuing decommissioning is expected to be steady, with a current reliance of 17% on nuclear power. Over the coming years to 2025, it is expected to be a nuclear-free country, in what may prove to be a giant gamble on an estimated €1 trillion investment into reliable energy and an increase in coal and oil imports. Expect some high energy prices in the near future. Now, to the UK. A conflicted energy policy here will likely see a decrease from its current 18% energy by nuclear power. All but one of its 16 current reactors will be shut down by 2030. However, there are currently 3 new reactor projects being funded by the private sector, meaning that more energy by nuclear power than currently predicted is very possible. The future of nuclear power here is still very unclear. France is heavily reliant on nuclear power. Currently 75% of its power is produced by 58 reactors, and a new generation reactor is currently being built. We are likely to see a small decrease in the number of reactors as France plans to decrease overall power generation by nuclear power to 50% for environmental and safety reasons. The future of nuclear power in Europe is a mixed picture, and only time will tell what is going to happen to the industry.